Magnetic fields, what are they? Or the different types of magnetism and how do they behave? The first type we're going to look at is a permanent magnet, which as the name suggests is always magnetized. Here is the field shape around a permanent magnet going from loops from the poles. How do we know the shape looks like this? We can use iron filings to show the shape on paper with a magnet underneath, or we can use a plotting compass with a north, south, east and west on it to find out which way the field is pointing. Normally compasses will point in one direction. They actually point towards the magnetic south pole, which I know seems weird. We'll come back to that later. So if you were to place them around a magnet, they would point towards the magnet's south pole instead of its north pole. You can try out this yourself at home. So away from north towards the south pole. So by doing that several times, we can come up with an overall field pattern, which looks like this with the field pointing from north to south. So, where is the field strongest? It's strongest at the poles. Both north and south are equally strong, equally attractive or repulsive. How do we know that? Because the field lines have the biggest concentration there. We should know two north poles will repel each other. How do we know that? You put them together, see what happens. A north and a south pole, opposite poles will attract each other. You need to know how to draw the field lines between those two poles. North poles will have field lines pointing away from each other. You still need to put the arrows on, but they should be pointing away. They should never cross over. Maybe a little bit neater than I've done there, but you get the general idea. Between a north and a south pole, the field lines point from north to south in a straight line, maybe a little bit curved depending on the shape of the magnet. Our next type of magnetism is called induced magnetism, or an induced magnet. It is not permanent. Induced magnetism is if you have a magnetic material such as iron and you put it close to a permanent magnet. Just going to redraw this a second so it gets a little bit closer. When you put it close enough, obviously we know it attracts to the bar magnet. Now, because a magnetic material like iron is magnetic, when in the presence of a magnetic field, the reason it attracts is because it turns into its own little bar magnet. That's called induced magnetism. So it would have, in this case, a north pole near the south pole of the magnet and the south pole at the other end. Now, this can occur with all magnetic materials. So iron, steel, cobalt and nickel are the ones that you'll be asked about at GCSE. So the definition for induced magnetism then, what you could be asked about in an exam, is a magnetic material, such as the ones we have just discussed, which become magnetized when placed in a magnetic field. Okay, so a lot of M words there, but that's the full definition. A magnetic material becoming magnetized when in a magnetic field, such as a bar magnet. Okay, last thing, which was the compasses I spoke about earlier, they point south. If you've done any Duke of Edinburgh, you will know they point towards geographic north. However, inside the Earth, you have a lot of, different cores and mantles and things, but you have a lot of molten iron sloshing around. Now, iron is a magnetic material which produces its own magnetic field inside the Earth. Now, that field happens to have a south pole, which is kind of near the geographic north, at a bit of a tilt for the Earth's axis, which I've drawn exaggerated there, meaning the Earth has a magnetic field just like a bar magnet does, but it actually has a south pole near the north.